Hello everybody. In this video we'll see one nice feature in Aspen Plus that we have not mentioned in any previous video, which is um, using Fortran to write codes to calculate data that you are interested in. So to demonstrate what I want to do, I'm gonna go back to the CSTR. I'm sorry, to the sensitivity analysis and go to the inputs. So what we did in the previous video is that we defined two manipulated variables, which was the volume of the CSTR and the temperature of the reaction. And we can choose which one of them to activate, or we can activate both if we want. And we defined the parameter that we are going to calculate, which is the flow rate of the product species, which was the ethyl acetate. And we tabulated this data. However, when we look at the analysis results, we can kind of understand that there is an increase, but we cannot feel the numbers well because it's just a flow rate. However, there are other parameters that we can calculate which are more informative. By this I mean the conversion of the reaction. So this is kind of thing that we can feel, and it's easy to compare how much conversion we achieved compared to what we will achieve if we increase the volume. So what I want to do is I want to calculate the conversion. Um, Unfortunately, conversion is not something that you can find in the sensitivity analysis here in the parameters that you can calculate. It's not any one of the parameters they can find here. So what you can do is to go here in the Fortran tab, which is available in many or almost all the blocks, but we have not used it yet. But this is where you can calculate any parameter that you want. So Fortran is a coding language that is used or has been used before, and it's still used in some software, which is one of them is the Aspen Plus. So what we want to do is to use this language to write a code to calculate the conversion of the reaction based on the data that we have. For those who are not familiar with the Fortran code, like myself, I'm not very familiar with it, but it's a very simple code, our language. So you can write what you want, and it's gonna do what you want to do. So, for instance, in our case, we want to calculate the conversion, and the conversion is the number of moles of the reacted reacting species, the limiting reactant, which has reacted, divided by the total amount that was fed to the reactor. So what we are going to do is to write this equation here, but we need to have all the parameters that we will write here or use in the calculations here have to be defined here in the define tab. So I don't have any of them here. All what I have is the product flow rate of the ethyl acetate. So it has nothing to do with the limiting reactant. If we go back to the feed stream, we will find that the flow rate of the mole flows where if we use them as kilomole per hour, so ethanol is less than acetic acid, and they all or both have the same stoichiometric coefficients of 1. So ethanol is the limiting reaction. So I need to in the Fortran code that I'm gonna write here, I wanna define the ethanol in the feed and the ethanol in the product stream. So I'm gonna make or define a new sample variable, which is ethanol in the feed, and I'm gonna define one more, which is ethanol in the product. And for the ethanol in the feed, I'm gonna define this as a stream, and it's gonna be mole flow, and it is for the feed, and it is of the ethanol. So it's now defined. For the product, it's gonna be the same thing. Everything is the same, with the difference in the stream, which is gonna be the product. I'm gonna go for ethanol. So I have all the parameters that I need to calculate the conversion are defined here in the define tab. So what I need to do now is to go in the Fortran tab and type here that the conversion is ethanol in the feed minus the ethanol in the product divided by the ethanol in the feed. So this is all what I need to do. So now the Fortran tab is what is totally defined. I need to have or get the results of the Fortran code being shown in the table. So I'm gonna add one more row here, and I'm gonna call or ask it to tabulate the conversion along with the flow rate of the ethyl acetate. So this is all what I need to do. Fortran is a simple coding language, and it's straightforward, so there is nothing tricky about it. So we will just go for or run the test or the sensitivity analysis, and now we will see that we have here another column which is the conv, and it starts with 64% and it's ending with 66%. I feel that I need to see this as percentage, so I'm gonna multiply this by 100, and again run the simulation and go for the sensitivity analysis results, and it's now shown as percentage. It's very simple, very nice, and very straightforward. We now can see the results curve as you can choose either one of them. So I'm gonna go for conversion and the volume as the x-axis, and this is what we have. So it's very nice actually. It's a very nice thing to see. So I started with 64%, 64.18% almost, at the volume of 100 liters, and by using 14 times this volume, I reached 66.2% conversion. So this is more easy to understand and to feel the number than it was before. One thing that I forgot to mention in the previous video is, or we can do here actually, because we have already calculated the conversion. It seems here that the volume is not enough, so we can, there is still some conversion going on, or increasing with the increase in the volume. So I can increase this volume to like a bigger number. I'm gonna go for 3,000 for instance, so that I'm using a very big number to make sure that everything or the reaction is gonna go to completion. So it's almost now completed at 66.3%, which this is what we call as the equilibrium conversion. So one thing that's nice is to see the effect of temperature on the equilibrium conversion. So what I'm gonna do now, so this is what we first tested, is the effect of the volume on the conversion. But this is at specific temperature, so we can stop this and activate this so that we can work at very low temperatures from 25 to 95 with, or make it 90 to with the increment of 2 for instance. Let it 24. And this is what we're gonna do. I'm gonna go for the CSTR and use this very big volume, so that I'm sure that the reaction has reached its endpoint or the equilibrium. So in the sensitivity analysis result, we will see that this is the equilibrium conversion. So we can now plot the equilibrium conversion as a function of temperature, which is something that we didn't see before. So we'll see here that as the temperature increases, the equilibrium conversion increases until it almost reaches a constant value here at 75, 76, something like that. And then and this point is the point that I used in the original simulation. And at this point, the ethanol starts to evaporate, and so the reaction, the equilibrium conversion declines. So we can stop at this point, and you'll see here that the temperature increases until it reaches a point where the increase in temperature is not adding more, because it has already reached the maximum conversion that it can do at this temperature. So the increase in temperature may lead to increase in the backward reaction, or it's not gonna increase anymore. So I won't just I just want you to go back to the 3 or 4 videos ago and revise the equilibrium constant and kind of try to understand why this behavior happens. The increase in temperature increases the rate, but it doesn't increase the equilibrium conversion, or you reach the maximum conversion, so you cannot exceed it. So I hope this Fortran thing helps. It solves some problems. And in the previous times when I was working with the Aspen Plus, I didn't know about the Fortran codes. I used to take the data to an Excel file, do all the calculations and everything like that. So here it's very time saving. You can do everything in the same place and the same software without the need of going back and forth between different softwares. So I hope it helps, and I'll see you in the next video, inshallah. Goodbye.